take out your notebook, there's a lot to do.
Mr. Kennedy here, your favorite math teacher. We've got a great lesson in store for you, so sharpen up those pencils. You do the math! Here's a few examples of words that have different types of symmetry. Remember, 180 degrees rotational symmetry is also called point symmetry. That's when you can flip it upside down and it's the same thing. Words with this property are called ambigrams. Check out these logos. Can you figure out the different types of symmetry? Watch what happens when I flip these two over the vertical axis. See, you can still read them. That's vertical line symmetry. Now look at these ambigrams. I'm going to rotate the entire frame 180 degrees. And it still says New X-Men, Paul McCartney, and Angels and Demons. That's point symmetry.
I did not know that.
Alright, mathematicians, let's see if we can come up with rules for how reflections work. So I rolled my dice and got 4, 2, so I'm going to plot the point 4, 2. There it is. Now I want to figure out how do I want to reflect this. So I spin the spinner, and it says reflect over the x-axis. So take my point and go down and flip it over the x-axis. There it is. So that looks like my new point is 4, -2. Alright, let's see what happens next. I'm going to roll the dice, and I'm going to spin the spinner. So I want to plot the point 5, 6, and it looks like I want to reflect it through the origin. So I'm going to go over 5 and up 6 on my coordinate plane. There's my point, and I'm going to shoot it right through the origin. So if I do that, looks like I'm going to have to go over back 5 on the x-axis, so negative, and down 6 on the y-axis. So my new point is -5, -6. So I'm rolling the dice, and I'm going to spin the spinner. So 4, 5 is my point. And we landed on the x-axis again, so instead of going through the process, I'm going to look at what happened last time, and I'm going to figure out what would happen this time. That's called a generalization. Tell me if you agree with what I have there. Alright, let's roll again. Mr. Kennedy needs a new protractor. And the spinner lands on the y-axis. So I'm going to take the point 6, 5. I'm going to plot it now, and then reflect it over the y-axis. So I go over 6, up 5, and I land right about there. Let's reflect that over the y-axis. So if I do that, go straight across, I'll end up about here. So that is -6, +5. Alright, I'm going to spin once more, 5, 2, and the spinner lands on, oh, just made it over the line y = x. So let me plot the point 5, 2, and this green dotted line is the line y = x. So if I flip over that, I land right here, which is 2, 5. Boy, time flies when you're doing math. Let's summarize what we just learned. Here's the common rules for reflections. Now, of course, those aren't all the rules, but here's some hints for reflecting over any line or through any point. Alright, now we're going to do some rotations. So 6, 4 is my first point. Let me plot that on the coordinate axis. Over 6, up 4, put a dot. And what I'm going to do is rotate this whole thing 90 degrees counterclockwise. That's the positive direction. And now I'm going to figure out where that point ended up. So it looks like back 4 and up 6. So that's -4, positive 6. So how is that related to the original coordinates, x comma y? Well, it seems like they switched, and the first one became negative. So negative y comma x would make sense to me. Alright, let's roll those dice. 5 comma 6. So I'm going to plot that point. Over 5 and up 6. Alright, I want to rotate this 180 degrees. So here's 90, and keep going one more time. Whoops, there's 180. So if you look real close, it's back 5 and down 6. So the coordinates stayed in the same order. 5 comma 6 became negative 5, negative 6. All that happened was they changed sign. That's the same as a reflection through the origin. So negative x, negative y is the rule. And one final time, roll the dice, 1 comma 3. Great point. So over 1 up 3, there it is, and I'm going to rotate this 270 degrees. So 90, 180, and 270. And if you look closely, it's over 3, down 1. So it looks like the order of the 2 points switched. Instead of 1, 3, it's 3, 1. And the second one became negative. So that would be y, comma, negative x. Those are the rules for rotations. I'm having so much fun, I forgot I was doing math! So again, here are the common rules for rotations. Note that when we rotated 180 degrees, it was the same result as reflecting through the origin. Alright, mathematicians, that's all the time we have for today. I hope you had fun. Until next time, I'm Mr. Kennedy. You do the math, and may the math be with you. I seem to be rotating. That's a transformation, by the way. I am rotating.